Okay, good morning, everyone. So we're starting Algebra 1. Now, what is Algebra 1 and what's the big deal of it? The idea for me, the way I think of Algebra 1, it's a series of tools that we use to solve for a missing variable. It's pretty much solve for an unknown. Like, we do this naturally all the time. Your parents will say, hey, let's go on a trip. We have 5 seats in the car. There's 4 people in the family. You can bring a friend because you have one extra person, and that's kind of an unknown. Now, who could that be? You know what? That's up to you. But we do this in many cases where we have money in our wallets and we're thinking about how much can I spend, how much should I save. That's in a sense an algebraic problem. You're solving for an unknown. How much are you able to spend? It comes with our time. We think about how much time to have to allocate to this, how much time to allocate to that. And that is an algebra logic problem that we always are kind of running through in our brains. But now we're writing this out in a math way, a math language that really only people who study algebra can understand. Like if you show this to your parents, they'll be like, huh? Why do you have numbers and letters? And there goes my first example. When I was in 6th grade, the first time I saw a variable was in 6th grade. And I remember the teacher said, okay, here's the problem. And the problem looked like this. It looked like x plus 3 equals to 8. And I was looking at the problem, and my first wondering was, why is there a letter there? X is, okay, A, B, C, D, E, F, G. What, X is like the 20-something letter? Oh, 20, right? And of course, the teacher was like, Edward, that's not right. And she said, X could be anything you want. So when she said anything I want, I thought it would be 20. Hey, anything means anything I want. I want it to be ice cream. But X really means what value could it be to solve for this whole equation? What X would be the perfect fit? Blank plus 3 would equal to 5. And what would that blank be? And you guys are all probably thinking, blank is 5. And this is one of our easy examples of algebra. Us using our critical thinking skills, the skills that we know already, like in the back of our brain, to solve this problem. And naturally, you could say 5 plus 3 is equal to 8. And this is pretty much a guess and check. X is equal to 5. X has to be 5 in order for this to become 8. If X was 6, if we said X was 6, so would 6 plus 3 equal to 8? Would that make any sense at all? Nope. So X cannot be 6. Can X be 4? 4 plus 3 is equal to 8. Is that true? Not a true statement. So X cannot be 4 either. There's actually only one solution in this case. And for our linear problems, what we call linear, there's only one solution. And as we first start this first semester of algebra, we only have one solution, and we want to find that one solution. So our goal is to learn techniques and methods to make this problem easier instead of having to guess and check in our brains. You can't guess and check every problem. I can make this problem harder, more steps, and as we get to more deeper problems, we'll reach problems that look even crazier like this. A problem like this. Now, when we see a problem like this, it is definitely harder for us to do in our head. But could we still guess and check? Sure, you can guess whatever number you want. A couple of tricks some of you guys might have figured out. Maybe I could find a number that's first divisible by 3. Numbers that are divisible by 3 are 3, 6, 9, 12, 15. Okay. And then from here, if I divide these by 3, then multiply that number by 5, and then subtract it by 4. Now, which of these options here, if I tried guessing, could I first divide by 3, then multiply by 5, and then subtract 4, and I would get 11. If I take my first option, 3 divided by 3, That is 1. 1 times 5 is 5. 5 minus 4 is 1. Nope, that's not even close to 11. If I do 6, let's do 9 as a guess. 5 over 3. What if x was 9? Nine divided by 3, let's do division first. I like doing division first, is 3. 3 times 5 becomes 15, and 15 minus 4 is 11. Hey, the answer would have been 9. But for us to guess and check, it is like the most silly way possible. It's a waste of our times. So our goal today is start off with our basics of learning techniques of when I see a problem, this is what I should do first to uncover what the variable should be. All right, so today we're going to do solving for simple one-step equations. Now, a couple things we want to take away here is the word equations. There's a big simple thing here, idea of equals. So everything that we're solving for must have an equal sign. We must have a goal. We want to say this mess on my left becomes a specific number. So let's come up with our first example. If I say 5 plus, sorry, other way around, x plus 5 is equal to, let's do 10. X plus 5 is equal to 10. We have an equal sign, so we're going to solve for what x will be to make this a true statement. Now, you guys are probably screaming in your houses, yeah, screaming, that this has to be 5. 5 plus 5 is 10, duh. So we're going to go through the methodology in which what we are thinking in order to solve this problem. And the first thing I would say is, what am I doing? What's the goal of this problem? And if it's to solve, the goal is to solve for the variable x. That is our goal. And in this basic idea of algebra, and actually much of math, our goal is to isolate x. So remember, we want the answer to look exactly like this. X equals to a number. Now I want you to see some similarities between where we start and where we end. Where we start and where we end. We start off with x and an equal sign, and we want to end with x by itself and an equal sign. So this is our goal here. Now, if I look back on the left side here, if you look on my left side here, what could I get rid of to get x alone by itself? Think of this as you being in a room all by yourself, which is nice. And then your parents come in, your mom comes in and says, hey, can we talk? What is your goal? What are you thinking in your brain? Leave, leave. So you have to find a way to get your mom to leave. Do you guys have any ways that you have created so far to get your parents to leave the room? I came up with one when I was a kid. I would tell my mom, in order so I could be alone, I would say, Mom, can you make me something to eat? And in my Asian culture, in many cultures, your mom will be like, sure, I'll be right back. Just wait here, no problem. And I would have an empty room again. In this case, we have to find a way, a method in which we could get rid of that 5. And our methods here is going to be called opposite operations. Opposite operations. And the opposite operations idea is, what is the opposite thing I can do so they would cancel out? So let's go through the opposite operations. The opposite operations of plus, the opposite operation is subtract, minus. The opposite operation of subtract is plus. These are opposite from each other. Now, to show you this, if I have a plus 5 and I minus 5 to it, they're opposite, so they cancel out. If I have a negative 3 and I add a positive 3 to it, hey, they cancel out. The opposite operation of multiplication is division, and the opposite operation of division is multiplication. So if I have a 5, so let's use the example of, if I started with 3 and I multiply this by 5, doesn't that make that 15? The opposite of this operation is divide by 5. And if I do that, let me rewrite it in a different way. The 5's divide out, and we're left with our original 3. The opposite operation of multiplication is division, and the opposite operation of division is multiplication. And if you look here on the right-hand side, we see that, hey, the 5 on top and the 5 on the bottom divide out, cancel each other out, leaving me a simple 3 behind. So these are our 4 simple operations that we can cancel out: addition, subtraction, multiplication, and division. And in your 4 years of math here at Hamilton, you'll realize that all math is, for the most part, is using these 4 tools. And as we learn new techniques, we find new techniques to cancel them out, our new opposite operations. So you guys might have remembered something called a square, like x squared. And the opposite operation of a square is actually a square root. If you have a cube, that would be a cube root. Does every operation have an opposite? Answer is no. Not every operation has an opposite, but almost everything that we're going to do, pretty much everything for this class, will have an opposite. So let's go ahead and look at our original problem again. If it's x plus 5 is equal to 8, okay? What is the opposite operation of plus 5? So looking back at our chart up here, the opposite operation of plus is minus. Opposite operation of plus is minus. Okay, so this is how we're going to write it. And then I'm going to show you guys, many of you guys have seen this before, but I'm going to write minus 5 to the bottom. Now in math, we call this an equal for a reason. That refers to that the left side of the equation, see this is my left side and this is my right side. This is my left and this is my right. The left side must equal to the right side. They must balance out. Now, if I subtract the left on my left side, you can't just let that go. You have to subtract the left from the 5 from the right side also. We subtract the left from the, we subtract the 5 from the left. That means we have to subtract 5 from the right. And this is a very simplified, organized way of writing it. In actuality, this is how we're supposed to write it every single time. X plus 5 minus 5 is equal to 8 minus 5. Now, I feel like writing it on the right side this way seems like it's going to be more work. I would have to have rewritten the whole problem so that I could write that negative 5 there. And this is officially the way it is working. I balanced the equation because I subtracted 5 to one side and the other. Now, one thing that you notice about the right side, it is kind of neat because I can see 5 minus 5. Doesn't that cancel out, become 0? Great. And isn't 8 minus 5 3? And that's, whoops. And that's exactly what happens. X is equal to 3. So when we're learning these techniques of opposite operation, there's specific correct ways of using it and incorrect ways. And writing it on the right side, this version over here is an absolute correct way. But we're going to come up with an understanding here. And the understanding is that instead of rewriting the whole problem, I'm just going to write a minus 5 on the bottom of both those, connecting like terms. So 5 minus 5, that cancels out, and 8 minus 5 becomes 3. And this is our main goal for this lesson, is isolating x so that we can say x is equal to what? In this case, x has to be 3 for this equation to be true. We can double check. If x is 3, x plus 5 is equal to 8. Is that true? Well, if x is 3, x became 3. So 3 plus 5 is 8, and that is absolutely correct. We are learning simple steps here, and algebra works like this. We are doing one step at a time, one undo operation at a time to get us to our solution. X is equal to 3. 3 plus 5 is 8. Now let's go ahead and try this one more time. If I say x plus, let's do a minus actually. Let's do x minus 4 is equal to 10. So some number minus 4 gave us 10. And you could start guessing this. 10 minus 4 is 6, too small. 11 minus 4 is 7. 12 minus 4 is 8. 13 minus 4 is 9. 14 minus 4, 14 minus 4 is 10. Hey, I got it. And actually, some of you guys are really good at doing mental math, and that's what you're doing. You might not start at 10. You might have started at 13 or 11 or 12, but you've practiced this enough that you can get there pretty quickly. But my goal here is to say, hey, sure, we can guess and check, but we also have tools now. Now, my first question is, what do we want to get rid of? Sorry, what are we solving for? First step, we are solving for x. So we want to get x alone. How do we get x alone? We got to get rid of a number. So the x is by itself. We have to get rid of the number 4. So that's our second idea. We have to get rid of the number 4 now. How do we get rid of the number -4? Opposite operation of a -4 is a +4. So I know I'm going to plus now on both sides. So x minus 4 is equal to 10. Opposite of -4 is +4. And if you notice, I wrote it not on one side, I wrote it on both sides, because an equal sign refers to I have to do everything the same to one side and as I would do to the other. This is a balanced equation. How many guys have brothers and sisters out there? And you've probably heard this before from your parents. Your parents will say, I love you all equally, right? I love you and you equally. We know that's a lie. Parents always have favorites. But if your mom gave you $5, what do they have to give to your brothers and sisters? They have to give them $5. It's only fair. If your mom gave you a $20 present, it's only fair that they give it to your siblings. It's only fair. If your parents take $5 from you, it's only fair that they take $5 from your siblings too. And the idea of this equal sign, it's a balance idea. The left side is balance with the right. So that's what we're doing here. We're balancing the left side with the right side. Now, a lot of kids, when they first do algebra, they'll actually make this mistake. And the mistake they'll make is this. They'll write it as +4 on the same side. Now, I want you to look at this illustration here. I gave the left side 4, and then I gave the left side 4 again. Does that look fair to you? If I give the left side, look, I gave the left side 4, and I gave the left side 4 again. That would be crazy, right? Your siblings would go mad over this. So we have to be careful, and this happens a lot because we totally don't understand what we're doing sometimes, and that happens in math, is that if I add 4 to one side, I must add 4 to both sides. And this is our invisible border of my left side and my right side. Well, if I do this, let's go ahead and finish the problem. So -4 plus 4 cancel out. So we're left with x by itself. Oh, poor x is now by itself. That's what we want. Is now equal to 14. Hey, that's our answer. That's what we had mental math, right? That's what we said was going to happen. Okay. I want you guys to solve this problem, and then we'll set up a poll for the answer. So we're going to say x minus 6 is equal to, let's do 3. Okay. Here's my example. I want you guys to go ahead and try this example. I'm going to set up a poll. You guys can give me an answer. Okay, so I saw a lot of great answers. So step 1, identify what's the variable. I see the variable is going to be x. 2, figure out what we want to get rid of. We want to get rid of the -6. The opposite operation of -6 is a add 6. So we're going to add 6 to both sides. Plus 6 to both sides. We see that we wanted to do the operation to cancel out on the left side. So x is by itself, and we're left with 9. Double check. 9 minus 6 is 3. Okay, sounds great. So we want to go through 2 more operations today, and that's going to be multiplication and division. Multiplication and division. So to look back at our chart, the opposite operation of multiplication is division, and the opposite of division is multiplication. So go forward and backwards. Now let's make sure that makes sense to us. So opposite operations. And with multiplication. Sorry, my handwriting is a little terrible. Okay, so if I take the number, let's say 10, something easy, and we multiply this by 4, this gives us 40. The opposite of multiply by 4 is divide. So if I divide by 4, that brings us back to 10. We could write it a little nicer way here. We can also write 40 divided by 4 is equal to 10. I think we're most comfortable with the right side. Going another way, if I say 12 divided by 3 is 4. Or we could also write 12 divided by 3 is 4. Let's do the opposite operation of division. Opposite operation of division is multiplication. So 4 times 3, right, because we're doing the opposite, that takes us back to where we started, 12. So that's our ground rules. Opposite of multiply is divide, and opposite of divide is multiply. Now, in algebra, we write multiplication like what you just saw, except that's our variable here. 3 times x. This could also be written as 3 parentheses x, or this could be written as 3x. These are all equivalent statements. I think all of us would agree that the one on the right would be the easiest for us to use. These are all equivalent statements. So whenever you see a number and a letter, this is always, for us, multiplication when they're right next to each other. What this isn't, if I write x cubed, this is not multiplication. This is exponents. And this is really x times x times x. And this is why we normally write numbers in front of variables. We write numbers in front of variables because we don't want to mix up the fact that it's multiplication. If I wrote this is not wrong if you meant that. But oftentimes, people confuse it with this. So that's why we do not write it this way in general. Is it completely wrong? No. But will a lot of people misread your numbers? Yes. So we don't write it that way. Okay, so let's give us a problem. 3x is equal to 12. Now, we'll follow our steps that we talked about before. Step 1. So sorry, I should write solve here. Step 1, identify the variable we're solving. I'm solving for x. That's step 1. Step 2, identify what I have to kick out so that x can be alone. I have to get rid of the 3. What is 3 doing to x? Do you see a plus sign? Do you see a subtraction sign? Do you see a multiply, or do you see a divide? According to the key on top, when numbers are next to letters, this is always a way of saying multiplication. So the opposite of multiply, opposite operations of multiply, I must divide. So we could write it this way. So the solution here is 3x divided by 3 is equal to 12 divided by 3. Now this is an official way that's perfectly legit. It's great. But I'm pretty sure you would agree with me. You don't want to keep writing that. So on the right side, this is completely right. This is a great way of writing it. This is the official way. But to make things easier on our lives, what we're going to do is I'm going to use the division line. If I divide it on one side, I'm going to divide on the other. And what number do we divide by? The opposite of times 3 is divide by 3. Okay, we divide it. We're left with x. Now, what is 12 divided by 3? 12 divided by 3 is 4. Another way for you guys to think of it is 3 times 4 is 12. And we can divide the 3 out. And we're left with 4. 3 divided by 3 is an invisible 1. Let's double check. Double check. We have 3 times 4 is equal to 12. Yes, that is 100% correct. Okay, now that we did multiplication, let's do division. Division is usually the trickiest one that people get most confused with. So let's do division now. If I say x divided by 4 is equal to 3. So we're going to ask ourselves to solve this problem. And we're going to go through the same exact rules that we went through before, the same exact steps. Step 1, identify the variable. We see the variable is x. Step 2, think about what numbers I have to get rid of. I got to get rid of the 4. How do I get rid of the 4? Well, is the 4 adding, subtracting, multiplying, or dividing? It is dividing. So the opposite operation of divide is multiply. So we're going to say x over 4 equals to 3, giving me myself some space. And I'm going to write parentheses 4 to both sides. Now, if you remember, this is one of the ways we write multiplication. I can write it with a parentheses. You could also have written it, I'm going to write the other ways you could write it. You could write x over 4 dot 4 equals to 3 dot 4. That is 100% okay also. Another method of writing multiplication. So let's go ahead and finish the left side. What is 4 divided by 4? Now, you could do it the long way. 4 times x is 4x over 4 equals to 12. And then you can divide it like this. You could do that. I find it easier to just go ahead and just cancel out right here to save space and save time. Since 4 is on top and 4 is on bottom, 4 divided by 4, 4 divided by 4 is equal to not nothing, equals to 1, and we don't have to write 1x. Let's do one more example of this. X divided by 5 equals to 20. Oftentimes, if people were being reckless, they would say 4. Oh, 4 divided by 5 is 20. Because we know 4 times 5 is 20. But let's go ahead and take our steps. Identify the variable. Decide what number you want to get rid of. Remember, we're not touching the 20 because 20 is not on the x side. We're going to try to get rid of everything from the x side, so the x can be alone. We want the answer to look like this. X by itself. X here is not by itself because of the 5. So we're going to have 5 to leave. 5 is dividing, so the opposite operation of division is multiplication. So let's go ahead and rewrite this. We use a dot now. The 5 divided by 5. What's 5 divided by 5? That's not nothing. It's invisible 1. X is equal to, and 5 times 20. 5 times 2 is 10. 0. It's going to be 100.